This is the review sheet for test number 3. That's graphs, polynomials, and radicals for advanced functions in modeling. I apologize and I'll go ahead and apologize now for the fact that the questions on the first few are pretty blurry with the graphs, but you should have your review sheet in front of you, so hopefully that'll be okay and you'll be able to follow along. So on number 1 it says, where is the graph increasing and decreasing? Okay, so I'm just going to draw in red where we're decreasing. And then also here, and then in blue where we're increasing. The key here is to focus on the x values. So we are decreasing from -4 until -1. And again from 2 to 5. Focus on the x-axis there. So then, increasing, we need to look from -1 to +2. So on increasing and decreasing, make sure to focus on the x values because you're making an interval with x values. Number 2, where's the graph increasing and decreasing? Again, I'll mark the decreasing parts and the increasing parts. Just think about moving from left to right, just like a roller coaster. So you start by increasing, and then down the hill you're decreasing. Well, this never really has a starting point. It goes forever to the left, so we're going to be increasing from -infinity all the way until 0. Don't put 4 because that's the y value. We're increasing until 0 because we're following the x-axis. And then we're decreasing also from 0 and then on out forever to infinity because it never stops. That arrow implies it just keeps going on forever. Okay, here we have state the domain and the range. Remember, domain is left and right, range is up and down. So domain, the farthest left we go is -4. The farthest right we go is +4. So my domain is from -4 to 4. And with domain and range, you have to be careful about parentheses versus brackets. Infinity and open circles get parentheses. Everything else gets brackets. So at -4, we have an open circle. It gets a parenthesis. At +4, we have a bracket because it's not an infinity or an open circle. So domain is left and right. It's all about the x values. Now range is up and down. It's all about the y values. I just remember in music, an instrument's range or a person's voice's range is how high or low of a note they can hit. So the lowest we go in the range is -4. The highest we go is +4. So I get -4 to +4. And again, infinities and open circles get parentheses. Everything else gets a bracket. So at -4 we would have a bracket. At +4, because of the open circle, we would have a parenthesis. So domain is left and right. It's the x values. Range is up and down. It's the y values. Again, state the domain and range. Well, if domain is left and right, domain, we never ever stop going left and we never ever stop going right. There's nothing there to tell us that we stop going either direction. So that means our domain will simply be from -infinity to +infinity. And our range is the y values. It's how high and how low we go. Well, the lowest we ever appear to go is -3. And it keeps on going up forever. Those arrows tell us we just go up forever. So we start at -3, and that'll have a bracket, and we go all the way up to infinity. So domain is left and right. It's the x values. Range is up and down. It's the y values. Always put the smaller number first. So always think left, right, down, up. Okay, state the max and min. So here you're just looking at, just like it's a roller coaster, for the bottom of a hill and the top of a hill. So that we would have minimums right here, and we would have a maximum right here. These you need to give me the ordered pair. So the ordered pair for the maximum would be at 0, 4. The ordered pair for the minimums, there's two of them. We would have it at -3, 1, and positive 3, 1. Again, just look for the peaks and the valleys, the top of a hill and the bottom of a valley. State the x and y intercepts. Okay, x-intercepts are where you hit the x-axis. That would be at -4 and positive 2. And you can just list those. You don't need to put any parentheses around them or anything like that. And the y-intercept is where you hit the y-axis, so that would be here, and that's a -3. So those should be pretty straightforward. X-intercepts, -4, 2. Y-intercepts, -3. 7. Find the value of f of 2 in the graph below. So in case you can't see it, it says f of 2. That's what it says right here. So f of 2. That means they want to know the value of f, that's our function, that's our y values, when x equals 2. Whatever's in parentheses is always an x value. So I go over to where x equals 2, and I find my graph. So I have the point right here. My x value is 2. My y value is 3. So f of 2 on this graph is 3. They're just telling you to go to where x equals 2 and find the y value. And here it would be 3. Is the graph below a function? Okay, to do that we need to use the vertical line test. So I'm going to make a vertical line, and we're going to pass over. As long as we only hit one point at a time, it is a function. So indeed, this is a function. We only ever hit one point at a time as we pass a vertical line over it. We're never hitting more than 1 point at a time. So this is a function. To give a quick example of something that would not be, if this did this, for example, then it would not be, because you can tell, like for example here, it hits it in 1, 2 points. If it hits in only 1 point at a time, it is a function. If it hits at more than 1 point at a time, it is not a function. So the way this one is drawn, it is indeed a function. Number 9, find the zeros of this function by hand. Okay, so we said each piece equal to 0. 5 equals 0, x minus 7 equals 0, x plus 2 squared equals 0. Well, 5 equals 0 doesn't make any sense. That can't be, so don't worry about it. Then here we add 7 to both sides, and we get x equals 7. Here we square root both sides and get x plus 2 equals 0, and then subtract 2 from both sides, so we get x equals 2. So 2 zeros, 7 and, -2. 7 and -2. Okay, this will be the last one I do on this video. I'll make a part 2 in a second video for the rest of them. But this wants us to find the zeros using our calculator. So I'm going to pull out the calculator, go to y equals, and plug this in. X raised to the 4th power minus 9x squared. So I go to the graph, and I think I'm a little bit zoomed in, so I'm going to zoom out to normal. So go to zoom 6 if your zoom looks funny. Okay, and you can see we have 1, 2, 3 zeros. Okay, 1, 2, 3 zeros. Now the easiest way to do this is to actually go back to y equals, and in y2 plug in 0. That's an important step, because if you're going to go to second calc and then 5 for intersect, you have to have that 0 in there. So let's move over and find the one on the left first. Okay, that's pretty close. Hit enter, enter, enter. So there's an intersection at -3. Okay, now we can do the same process. Second calc, hit 5 for intersect, and we try to go to the middle one. So we hit enter, enter, enter. And the intersection is at 0. Okay, you can see that right here. Intersection is at 0. Okay, finally we'll do the one on the right hand side. Second calc, 5 for intersect, think I went too far, sorry. Okay, there we go. It's real close now. Hit enter, enter, enter. And it's also at positive 3. Let me give you one quick tip and then I'll close this one out. Sometimes when it just hits the x-axis like it does right here, but doesn't cross it, the intersect button doesn't work. So another alternative there is to either use the max or the min button. You can see that would be a maximum, that would be a peak. So you can also do second calc 4 for maximum, and then you can go and be just to the left of it, enter, just to the right of it, enter, and then don't worry about guessing, just enter again. And those numbers, though they look crazy, really are 0. Whenever you see E followed by negative numbers, your calculator is just having trouble being exact. But those are really tiny numbers, so it would be 0, 0.